Now, class, picking up where we left off at, we'll be on problem 16. It says solve the system below using each of the following methods. Now, as you see here, I gave myself some room, so you may need a separate sheet of paper in order to write out how to solve this. Now, we know the addition method and elimination method is the same thing. So we look here at these two equations, and we determine which variable we want to get rid of. Now, I would suggest that we get rid of the y's because they already have opposite signs. Now, if you look here, we'll look at the coefficient of y and negative 2y. Now, we know it's assumed that it's a 1 in front of this y. So if these were denominators of a fraction, we would ask ourselves, what does 1 and 2 have in common? And we know it would be 2. So this bottom equation already has 2 in front of y. But the top equation does not. So we ask ourselves, 1 times what gives us 2? We know it's 2. So we would take 2 and multiply it by this top equation. And then we would bring down the bottom equation. So we'll multiply 2. This will give us 4x plus 2y equals negative 14. Then we add 3x minus 2y will give us negative 7. So if you see here, these y's will simplify out to 0. 4 plus 3x is 7x. And negative 14 minus 7 is a negative 21. Now we would divide each side by 7. And x is negative 3. Now, we know what x is. We want to find out what y is equal to. So we could take one of the two original equations here and substitute in negative 2 for x. So now, I would choose to use the top equation. Doesn't matter which one you use. So I'll substitute in negative 3 for x. 2 times negative 3 we know is negative 6. Plus y is 7. We would add 6 on both sides. Well, actually, this is negative 7. So we will add 6 on both sides, and y is equal to a negative 1. So now we will write our ordered pair. Our ordered pair would be negative 3, negative 1. And that is our final answer. Now, when we do the substitution in the graphing method, it still should give us negative 3, negative 1 for our answer. So now, in using the substitution method, this method basically calls for you to take one of these equations, one of these two original equations, and get one of the variables by itself. It doesn't matter which variable. So I would choose the top because all I would have to do is subtract 2x on both sides and y is by itself. So I take 2x plus y equals negative 7. Subtract 2x on both sides. So I have y equals negative 2x minus 7. Now, I would take this value here and substitute it in the equation that we did not get the variable by itself. So in this case, it would be the bottom equation. So I had 3x minus 2. Then I'll substitute this value in for y, the negative 2x minus 7. And that equals negative 7. So now we will add 3x, negative 2 times a negative 2x is a positive 4x. Negative 2 times negative 7 is positive 14, and that equals negative 7. So this will give us 7x plus 14 equals negative 7. So we will subtract 14 on both sides, and 7x equals negative 21. We'll divide each side by 7, and x is negative 3. So now, we got our x is negative 3. So we could go to one of these two original equations, or we could go to the equation that we got the variable by itself and substitute in negative 3. I think I will go to the equation that we got the variable by itself and substitute in this negative 3. So it'll be y equals negative 2 times negative 3 minus 7. So it'll be y equals 6 minus 7. And we know 6 minus 7 will give us negative 1. So it still gives us the ordered pair negative 3, negative 1, even though we used a different method. Now, we come here to the last method, which is graphing. Now this is what you need to do for graphing. I'm going to draw a little line here so we'll know that this does not go with this the graphing portion. Okay, what you need to do for graphing is to get y by itself. Now, we already got y by itself in the first equation. So we can write that down here. So we know one of our equations would be y equals negative 2x minus 7. Now we have to find the other equation. So we would take 3x minus 2y equals negative 7. We'll subtract 3x on both sides. We will have negative 2y equals negative 3x minus 7. We'll divide each individual term by negative 2. And we will have y is equal to a positive 3/2 x plus 7/2. So this will be our other y equation. Y equals 3/2 x plus 7/2. Now that we have both of these in the y equals or y by itself, we can go to our calculator. We can go to y equals, clear out whatever we have in the calculator, and then we could type in these equations. We will have negative 2, and then we know x is by the lime green alpha key, minus 7, and press enter. Then we will go to the next one. Now this is 3/2 x. We can do a parenthesis, 3 divided by 2. Close the parenthesis and put x, and then plus, we don't need to put the 7 divided by 2 in the parenthesis. So now we will press graph. Now if you look here at the graph, you see we have an intersection point. So what you would do to get the intersection point is, you will press the second function key, and then you will click on trace. So if you press second and trace, it gives you calculate. Now with calculate, if you look here at the number 5, it says intersect. So you'll press number 5, then you'll press enter 3 times. And it gives you your intersection with x is negative 3 and x is negative 1, which is the same thing that we have here. I mean, y is negative 1, which is the same thing we have here. So the ordered pair is still negative 3, negative 1. So these are the 3 methods that you have at your disposal. Now we scroll down here to 17. Now 17 is more of the same, but they tell you to use the method of your choice. So that's what I'm going to do. I'm going to continuously do the method of my choice here. This will go a lot faster than what we had before. Now with A here, we notice that x is by itself. So that means we can use the substitution method. So we can substitute in 3y minus 9 in the second equation plus 2y equals 1. So now we notice there's nothing we can do inside this parenthesis. So we have 3y minus 9 plus 2y equals 1. 3y plus 2y is 5y. Minus 9 equals 1. We add 9 on both sides, and 5y equals 10. We divide each side by 5, and we know y will give us 2. Now that's the first part. Now we have to find out what x is. Now for some reason that y equal 2 disappeared, so I'll write it over here. So that's y equals 2. So now I will pick the first equation, because once we substitute in 2 for y, then our final answer would be our x value. So we would take x is equal to 3 times 2 minus 9. 3 times 2 we know is 6. And 6 minus 9 will give us negative 3. So we will have x is equal to negative 3. So we will have x is negative 3 and y is 2. So our ordered pair here would be, and the x is negative 3 disappeared. Our ordered pair would be negative 3, 2. And that would be our final answer. Now, we come here to B. Now, if you notice, we don't have any variables by itself. But when I look at this is, we can use the elimination method. Now, what I would do is, it doesn't matter which one I pick. So which one do you all want me to get rid of? The x's or the y's? Which one? The y's, okay. So we're going to get rid of the y's. So remember, we look at these coefficients as denominator of a fraction. With 3 and 4, we know that they have 12 in common. That's their least common multiple. So we know that we will have to multiply this top equation by 4 and this bottom equation by 3. This would make our y's equal 12. But since they have the same sign, one of these will have to be negative. It doesn't matter which one, so I'll pick the bottom one. So we have 8x plus 12y is equal to negative 20. Then we will have negative 9x minus 12y is equal to 24. 8x minus 9x is negative x. Negative 20 plus 24 would be 4. We'll divide each side by negative 1, and x is negative 4. So now, we have our x value here. So we need to go back up to one of these two original equations and substitute in negative 4 for x. It doesn't matter which one. So I'm going to pick the top. So I had 2 times negative 4 plus 3y equals negative 5. 2 times negative 4 is negative 8 plus 3y equals negative 5. We'll add 8 on both sides. And we'll add 3y equals 3. Divide each side by 3, and y is 1. So we have x is negative 4, y is 1. So our ordered pair will be negative 4, comma 1. That will be our final answer. Now if you look here at C, we have for C here, we have x minus 2y equals 5 and y equals x minus 7. Now for me, since we have y by itself with one of these equations, I would just go ahead and get y by itself in the other equation, because then we could put this in a calculator. So this would just give us practice here. So we would take this x minus 2y equals 5. So we would subtract x on both sides. And we add negative 2y equals negative x plus 5. We divide each individual term by negative 2. And this would give us y is equal to 1/2 x minus 5 halves. So we have our two equations. We have this y equals x minus 7. We can put in our y equals here. Let's clear this out. So we have y equals x minus 7. And we'll press enter. And then we will have 1/2 x, which we know is just 0.5. 0.5x minus 5 over 2, we know is 2.5. So now we'll press graph. Now if you notice here, it intersects. So we'll press second, trace, the number 5, then we'll press enter 3 times. And our intersection is 9, 2. So our final answer here is x is 9 and y is 2. That is the final answer for that problem. Now we scroll down. We have a few more of these. We have D, E, and F. Now D here, if you notice, we have opposite signs for the x's and y's. This time I'm going to get rid of the x's. The lead coefficient, the common coefficient of these two would be 4. So we know we would need to multiply this top equation by 2. So we have 4x plus 2y equals 6. Be negative 4x minus 2y equals 6. So this will end up being 0 equals 12. So we know that does not equal, so it's no solution. Now, we come here to E. Now, if you notice here with E, we do have a fraction in this second equation. I would suggest let's get rid of the fraction first before we do anything. So we find a common denominator of 4 and 3, which we know is 12. So we'll multiply this whole equation by 12.